What's up C peeps, I'm Divesh Thakker and welcome to our channel Learn Competitive Programming with CodeChef. Now if you have still not subscribed to the channel, do hit the subscribe button to stay tuned with us and let's get started. So today we would understand the problem statement by taking a help of an example. Next we would look at all the possibilities. So basically your observation skills needs to be good to solve this problem. So we would make a note of all the observations we see in this problem, and while making those observations we would also be forming our pseudocode for this problem, and finally we would look at the code for this problem. Now for Learn Competitive Programming with CodeChef, hashtag let's crack it. If you have still not subscribed and got your subscription membership, do take the referral code provided on the screen to get a 10% discount on your subscription. So do check that out and let's get started with our problem. So let's start off with this problem. First of all, I want you guys to read the problem statement. So go through the problem statement, go through all the terms which have been used. Now you would say, hey, I did not understand some part of this problem statement. So now let us understand this problem statement by taking a help of an example. Let's suppose that I have been given an array. Now this is any random array which I have taken. First of all, remember one thing. While solving this problem throughout the video, we would always be working with sorted arrays, right? So in this case, first of all what you would do is you would take the input and you would sort it. Okay, so I have sorted the array. Now let's take this sorted array as our input. Now if you see, let's suppose that the value of p is 4 and the value of k is 6. Okay, let's suppose that the value of x is 3. Now if you see what the problem exactly asks me to do, what we need to do is we need to output the minimum number of operations required to transform the element at position p to the value of x. So in this case a of p is 3. We need to transform the pth smallest element to the value of x, which is 3. Now if you see, why did we sort the array? Because we have been told to work on with the pth smallest element and the kth smallest element, right? That is the reason we would be sorting the array. So in short, we want to get the value of x at the position p of our array, right? Okay, now let's say that we can perform some number of operations to achieve this task. Now what is an operation? In this problem, it has been defined that an operation is the kth smallest integer of an array, and we can perform an operation by changing the value at the kth position with any value we want, right? So we can replace this value at position k with any value we want, and by performing these operations, by performing some number of operations, we need to get the value of x at position p. Okay, so now let's start off. Let's start off by performing some number of operations. Let's say that I'm replacing the value of a of k, which is 7 at present, with 3. Now why? Because I want 3, right? So let's say I'm performing an operation. If you see the red frame, you see that the value at a of p has changed, right? So I have performed an operation and now I've sorted the array, and this is what we have. Let's suppose that I'm performing one more operation. Let's say I'm replacing the value a of k, which is currently 5, with 1. So after replacing it and after sorting the array looks something like this. Now if you notice, the value at a of p is 3, which exactly is what we wanted, right? So in this case, we have performed the smallest number of operations to get this value x equal to 3 at a of k, and that is the reason we would be printing 2 as our output. Now in this problem, we have numerous number of possibilities, right? So the key thing here is, okay, I took this example to make you guys understand what the problem statement is exactly trying to tell us, right? But how to solve this problem? First of all, you need to make note of different possibilities, different observations in this problem, and let's start off by doing that. So here I have created a panel for our observations. And let us continue with the same example which we had taken before, right? So I've taken the very same example. Now let us look at all the possibilities. First of all, we have been given the values p, k, x as our input, right, along with the array. So if you look at k and p, there are 3 possibilities, right? You would say, hey, either the value of k is greater than p, either the value of k is less than p, or you can say the value of k and p can be equal. So if you see, we have made three observations there, right? We have k greater than p, else we have k less than p, else we have k equal to p. If you see, when k is greater than p, k comes to the right of p, right? Similarly, when k is less than p, k comes to the left of p. And when k and p are equal, they are at the same position. Okay, first of all, we would be representing k with blue and the p value with red. Okay, now let's move on to the first case and the observations. If you see, the value of k is greater than p. So let's continue on the same example. This is the very same example which we took, right? Let's suppose that the value of k comes after p. Now in this case, again there is a comparison. If you look at the value of a of p, which is 5, and if you look at the value of x, you can also have a comparison, right? There are two possibilities. Either the value of x is greater than a of p, or it is less than a of p. Let's assume the first condition where the value of x is greater than a of p. So here if you see, the value of a of p is 5 and the value of x is 6. Now let's start off by performing some operations. So what we need to do is, at that red frame, you need to get the value 6, right, by performing some number of operations. So let's start off by replacing the value of a of k, which is 7 at present, with 11. If you see, this is the sorted array after performing the operation. Okay, now let us replace the value a of k, which is 9, with 3. If you see, this is the array which we have after performing this operation. Now, if you notice one thing very carefully, the value of a of p remains the same, which is 5, if you replace the number at the kth position with a value greater than 5, right? 5 is a of p, so if you replace it with greater than 5, in the first case, if you see, the red frame has the same element, right? It does not change. Similarly, when you replace the element with a number which is less than 5, if you replace a of k with a number which is less than 5, which is less than a of p, then unfortunately your red frame, the number decreases, but the value is 6, greater than a of p. It should have been increasing, right? So if you see, in all the possibilities, when the value of x is greater than a of p, in this case, it is impossible for us to get the value x equal to 6 at a of p, right? You perform infinite number of operations. For this particular example, it is not possible to get the value, and hence we would be printing -1 in this case. Okay, so we got a case where k is greater than p, and if x is greater than a of p, then you have no option and it is impossible, and hence you will be printing a -1. Okay, now let's move on to the next part, next else if condition, where k is less than p. So I have taken the value of k comes before p to the left of p, and k is less than p. Let's suppose that the value of x is 4, which is less than a of p. The value of a of p is 7, the value of x is 4. Now, let's try to perform some operations. Let's say I'm replacing a of k, which is 5, with 3. If you notice, this is our array after this operation. Okay, now let's try to perform a of k with a value which is kind of greater than a of k, let's say 11. If you see, this is the array after this operation. Now similarly, if you make the observation, you would see that if you're replacing the value of a of k with a number which is less than 7, then the red frame number is not changing. And unfortunately, if you're replacing it with a number which is greater than a of p, then it is unfortunately increasing. But the value of x is less than a of p, which means the red frame number should have decreased, but here it is increasing. What I mean to say is, again in this condition, it is impossible for us to get the value of x by performing infinite number of operations, and hence we would be outputting the value -1 in this case as well. So if you see, don't you think this is kind of a symmetry? If you look at the first and the second observations, what we observe is we have looked at the cases for x, for k and p, corresponding for x and the value of ap, that for these particular cases in the observations panel, you can see that you would be printing a -1. Okay, now let's continue with the very first example. Let's move on to the very first case where k is greater than p when k comes after p. So this is the very same example, right? Now let us move on to the else part of it. Let's suppose that the value of x is less than a of p. We have looked at x greater than a of p, we will be printing -1. Let's look at if the value of x is less than a of p. Now if you see, since we want the minimum number of operations, we would replace a of k with a number which is less than a of p, because we want the minimum number of operations, right? And if you see, we have already performed this. If you notice, this is the exact same example which we took while I was explaining you the problem statement, right? We have performed two number of operations to get the value x equal to 3 at the desired location. But now, how would we calculate this without actually, changing the elements of the array and sorting it each and every time, because that is very difficult, right? So to solve this, the technique is, what you would do is the number which you want, the value of x, you would first take it to the desired position. Okay, so you're not adding it, but you just know that here is x. Now you would start off, first of all you would take the answer variable. Now the answer variable is the number of operations we would be performing, right? Because we know that this condition is valid, we've already seen it. So now let's go on to find the answer. Let's find the smallest number of operations required to get the value of x at this position p, currently which is holding 5. Okay, so you would be starting from a of p, remember, and in this case you would be moving to the left. Now we are starting from a of p, right from a of p, and we are checking till the element a of I is greater than x. We would be including that in our number of operations, and we would increment the number of operations by 1. So starting from a of p, here a of p is 5 and 5 is greater than 3, that is the reason I have incremented the answer variable by 1. Moving on to the left, we have 4, and again 4 is greater than 3, so we take the answer variable incremented by 1. And now if you see, 3 is not greater than 3, so until we reach that 3, we loop into the left starting from a of p, and the answer, the value which we get inside the answer variable will be the smallest number of operations required. So for this case, we would be outputting the answer as 2. Okay, now let's move on to the other condition when k is less than p, when k comes to the left of p. And we have already looked at the -1 condition, right, when x is less than a of p. But what about the value of x is greater than a of p? As in this example, let's suppose that the value of a of p is 7 and the value of x we have been taking is 8. Definitely we would take in the answer variable. Again, since we want the minimum number of operations, this time we would be replacing a of k with a number greater than 7, right? So definitely we would be taking the value x equal to 8, taking it at the position, and now by performing the similar way, what we do is we start off from a of p, we consider that, and we move to the right until the values are less than x. If you calculate, you start off with 7 and you move on, you get the answer to be 1, right? Because you take in 7, then you find it 8. So in this way, in a similar way, you just move on to the right instead of the left, and you calculate the smallest number of operations required to get that x value, and in this case you will be printing the answer as 1. Now finally we have explored all these possibilities when k is greater than p and k is less than p. Now let's move on to the else part, where the value of k and p are same. So let's suppose that the value of k and p, the index is exactly the same. So definitely a of p would be 5, right here is right. So now let us compare the values of x. Let's compare the values of x with a of p. If you compare, there are again two possibilities, right? X is less than a of p or x is greater than a of p. Let's suppose that the value of x is less than a of p. Let's take the value of x as 1. Now you would do this in a similar way which we have already seen in the first case, right? What we do is we take the value of x, we virtually put it at the position, and then again we start off from the a of p position and we move on to the left until all the elements we encounter are greater than x. If they are, we increment the answer variable by 1, right? So we start off 5 is greater than 1, 5 is greater than 1, 4 is greater than 1, and 2 is greater than 1. Now until we increment 1, we see that the answer variable is 4, and hence we would be outputting that as our answer. So if you saw, if the value of k and p are equal and the value of x is less than a of p, then we would be printing the answer in a similar fashion while moving to the left side. Now let's move on to the other case where the value of x is greater than a of p. Let's suppose 9. In this case as well, if you calculate, you would see that the value of your answer will be 2. It's similar, right? We start off from a of p and we move on to the right side until all the elements we encounter are less than x, right? So if you start off from 5, you have 5 and 7, and hence you would be outputting the value as 2. Now let us, the example is, the observation is almost completed. Now let's move on to one simple condition which I want to tell you. Now you may ask, hey, what if the value of k and x, p are the same, and the value of a of p and x are also the same? For this large simple condition, what do you think? What would be the answer? It's simple, right? If the value of x and a of p are the same and k and p are same, then you don't need to perform any number of operations. You need to perform 0 number of operations, right? Because already you have the desired value. In this case, you will be outputting 0 as your answer. So just a quick summary at the observations panel. That's what is, it's not kind of a pseudocode, it's actually the code if you just know how to get that answer which we have already discussed. So guys, that is it. These are the observations which you needed to make to solve this problem. And now I would highly encourage you, before continuing the video with the solution, go on to the IDE, go on to the editor, write the code, try it by yourself and get that AC. The pseudocode will help you. This is exactly the same which you require. And now let's move on to the code. So let's move on to the code to this problem. Here I have used C++. Now if you notice, the code doesn't really matter because it is kind of exactly the same as the pseudocode we have already looked at. Okay, so let's start off. Here if you see, this is just kind of fast input. I have taken my t and I am inputting t. Similarly, for these t test cases, I have 4 variables n, x, p and k, and correspondingly I am taking them as my inputs. Again, I have my nums array, which is a array which we had seen, and I am taking that as well for my input. Now at line 13, I am for the first and last time sorting this array, right? So I have an array, I am sorting it. Now count. This count variable is the variable which is the number of operations we have performed. So the count variable is what we would be printing to the output. Okay, so let's start off with our 3 conditions. Let's take on for the last condition where we had the same index, right? So if k equal to p, we have the same index. In that case, what we do is we compare and we see that if x is less than t, right? T is here nums of I or p or nums of p or a of I. So we see that if x is less than a of I, then we have an answer and we move on to the left side, right? So I have just applied a basic while loop over here and I move on to the left side. This is just to check if my array is not going out of bounds, and while the number is greater than x, I increment my count or the number of operations I am performing, and finally for this condition I am outputting my count. Similarly, if x is equal to t, this is the most simple condition, we simply print out 0. And the third condition where the value of x is greater than t, t is a of p, so if x is greater than a of p, we move on to the right side. So here I have simply applied a while loop and I do a count plus plus just to check the array index out of bounds, and here we print out the answer. So this is the third case which we had, right? Now let's move on to the second condition. Here let's say the value of k is less than p, right? So this was the second condition. Again, we had this condition where you would be printing a -1, else we know that we would be printing an answer. So in this case, we move on to the right side and we check and we apply basic while loop to move on to the right side to check. This is just to check the array index, and until you have the element which is less than x, you increment the count, which is the number of operations you are performing, and at the end you are simply printing your answer. Similarly, let's move on to the first condition. The first condition was k is greater than b. So here, if x is greater than nums of a of p, then you print a negative 1. Else, we know that the answer always exists, so we move on to the left side, and here we just apply the same while loop to check if the number is until it is greater than x, we would increment your answer. And finally, this is just to check your array index bound out of bounds, and we print out the answer. So this is exactly the same pseudocode which we had written with some while loops inside it. So that's the solution for this problem, replace for x.